Welcome to this lesson on lines and angles in geometry. First relationship we'll be looking at is called adjacent angles. That's when you have two angles that share a common side. So notice angle A and angle B share a common side, which is this line right here. Because they share a common side, we can say that they are adjacent angles. Further, angle A and angle B together form a straight line. When two angles form a straight line, we call them a linear pair. So angle A and angle B can be referred to as a linear pair. Let's take that idea and develop it further. What if you added the measure of angle A to the measure of angle B? Let's say, for instance, angle B was 80 degrees. What would angle A have to be? Angle A would have to be 100 degrees. Why is that? Because a straight line equals 180 degrees. So angle A plus angle B is 180. And this is another concept that you really need to know, that when two angles add together to equal 180, we call them supplementary angles. The next relationship we'll be looking at today is the vertical angles relationship. Vertical angles happen anytime you have two lines intersecting. It doesn't have to be two, it could be more than two lines, 3 lines, 4 lines, whatever it is. But the bottom line is you have vertical angles when lines intersect. So let's take a look at this setup here. An example of vertical angles would be angle 1 being vertical to angle 2. And of course, the other pair would be angle 3 is vertical to angle 4. Vertical angles are congruent, so that means if you knew the measure of angle 3 to be 100 degrees, well, angle 4 would also have to be 100 degrees because they're congruent. And of course, angle 1 would be 80 degrees, and that means angle 2 would also be 80 degrees. Notice that angle 1 and 3 are adjacent to each other, and they form a linear pair, 1 and 3. And when you add them, they equal 180. That's basically the same idea we just learned from the previous concept. The third idea and concept that we ought to be familiar with for the SAT and ACT is the idea around parallel lines and transversals. So parallel lines are lines that never intersect. An example would be this line right here, never intersects that line right there. And if you have a line that's intersecting parallel lines, like line T right here, that's called a transversal. The reason why that's important is when parallel lines and transversals intersect, we have angles that pop up. In this case, we have 8 different angles that result from those lines intersecting. And those angles are related. There are congruent relationships between these angles. Let's go ahead and explore those. The first relationship is the vertical angles theorem, whereby vertical angles would be congruent. An example, looking at this point right here, vertical angles would be angle 1 being congruent to angle 3 because they're vertical. Of course, we have angle 2 being congruent to angle 4. And on the bottom cluster right here, angle 5 is congruent to angle 7. And last but not least, angle 6 is congruent to angle 8. That completes the vertical angle relationship. The next relationship is the alternate interior angles relationship. Alternating means on opposite sides of the transversal. So if one is on the right side of the transversal, the other one will be on the left side. And interior means it's going to be inside of the two parallel lines in this space right here, not outside of it. So an example of those would be angle 3 and 5, alternating interior. So I'm just going to say angle 3 and 5 because it's easier to write it this way. And the other pair is angle 4 and 6, angle 4 and angle 6. So basically, if you know angle 3, you definitely know angle 5 because they're equal. If you know angle 4, you definitely know angle 6 because they're congruent or equal. The next relationship is alternate exterior angles. Of course, that's a lot like the alternate interior, except for the angles are now on the outside. in this region and this region of the two parallel lines. So alternating in exterior, we would have angle 1 and angle 7. Those are congruent. So if you have angle 1, you definitely have angle 7 because they're equal, they're congruent. And another example is angle 2 and angle 8. Our next relationship is the corresponding angles. Corresponding angles are angles that occupy the same position just on different lines. An example of that would be angle 2 is on the top right side of that intersection. It's corresponding to angle 6, which is also on the top right of that intersection. So an example is angle 2 and 6. Another one is angle 3 and angle 7 on the bottom right. Angle 3 and angle 7. And of course, these are all congruent. If you have one, you have the other. And on the left side of that line, angle 1 and angle 5. Angle 1 and angle 5. And of course, angle 4 and angle 8. So the last relationship I want to bring to your attention here is the same side interior and same side exterior. Same side interior and exterior are supplementary. That means if you have 3 and 6, those are on the same side of the transversal and they are inside of those parallel lines, those two angles would add up to 180. Same thing with the same side exterior. So angle 2 and angle 7, if you add them together, they equal 180. And of course, still on the interior, angle 4 plus angle 5 equals 180. And last but not least, angle 1 plus angle 8 equals 180. So same side interior and exterior angles add up to 180. That means they are supplementary. Remember, angles that add up to 180 are known as supplementary angles. Now, one last concept I'd like to introduce as far as lines and angles are concerned is the exterior angle theorem. And this theorem tells you that if you took two angles that are inside of a triangle and added them together, in this case it would be angle 1 plus angle 2, they're going to equal the external angle that is across from them. So they would equal angle 4. And that's called the exterior angle theorem. Two interior angles add up to the exterior angle across from them.